After teaching for 36 years in schools with physics laboratories, it's been very interesting to try and do this at home without any help and also with no proper apparatus. So I've been raiding the cupboards in the kitchen and around the house and the garage to find things. And we've got a set of things here that we're going to use now. It's also interesting how inanimate objects that I've done no harm to seem to leap up and attack me like balls that bounce quite calmly, magnets to behave themselves until I turn the camera on, and then they become wild objects that I can't control. Well, let's see how we manage with these. This experiment is to look at falling objects. Now you'll notice that in a certain time it fell at a certain distance. What I want to do, and you need to investigate this yourselves, is how far do cupcakes holders fall in a certain time? Does the distance vary with the mass? Now, there's one cupcake holder. If I put one inside the other, that makes two cupcake holders. Now, if we were going to measure the time, does that fall further than the first one? Now, the beauty of it is the air resistance is pretty much the same each time. If I now try it with 3 cupcake holders, a bit more violent, 4 cupcake holders, 5 cupcake holders, and so on and so on. And you can plot a graph of the distance fallen in a certain time, or if you like, the time to fall a given distance. Now see if you can get an equation that relates the mass, the time and the distance. I'll just give you one answer to part of it, that the distance fallen in a given time is proportional to the square root of the mass. There's about 6 or so in that. And here's the single one again. Notice the single one glides down much more slowly. A fascinating little experiment, very cheap, but the theory behind it, well, see if you can work out the equation.